Hi. The select statement can analyze data brilliantly. For many years now, even decades. It filters rows easily. It can join different data sets in various ways. It can aggregate data nicely. It can even analyze moving windows of data in a really clever way. And today, we'll take it to the next level, looking for sequences of rows and detecting patterns in these sequences. We could do it in the past, in a way, but these queries were usually cumbersome, non-elegant, and many times suffered from poor performance. Until version 12.1 of Oracle, where the SQL select statement got a wonderful extension, the match recognize clause. Match recognize allows us to perform enhanced analysis of row sequences and to detect sequences that match complex patterns. It gave a significant boost to the analytical capabilities of SQL. It allows to perform various types of problems in a simpler way than before, in more elegant way than before, and many times in better performance than before. It is very powerful, and as we all know, with great power comes complex syntax. And this complex syntax intimidates many developers, and I think it's pity. In my opinion, match recognize should be in the toolbox of every Oracle developer. So the purpose of this session is to start using pattern matching. And we'll do it in small bites, step by step, with simple examples. We will not cover all the capabilities of pattern matching, but we will cover quite a lot, and I'll give some recommended links at the end, so you can continue exploring this wonderful feature. My name is Oren Akdimon. I'm an Oracle ACE director from Israel. I am an Oracle developer for 30 years now. Since 2012, I work for MoveIt, where I'm responsible for the database development. I use the nickname DB-oriented for my activity in the Oracle users community. I'm a member of Symposium 42, an independent organization for the Oracle community, by the Oracle community. And I'm active in the Israeli Oracle user group. I tweet about Oracle stuff. You are welcome to follow. And I write about Oracle stuff in my personal blog, dboriented.com. I'd like to start with a real-life example where I found pattern matching very useful in my work at MoveIt. MoveIt is the leading app for urban mobility, and one of the basic features is showing all the departure times of a specific line, bus line, train, subway, etc., in a specific day. But when there are many departures at the same day for the same line, the list becomes too long. We wanted an alternative view for the same data, frequency-based ranges. And you can see this is the same data, but it's much nicer in this view. And this conversion of concrete departure times to frequency-based ranges is done by a select statement using pattern matching. And we use pattern matching to detect both the frequencies and the ranges. Pretty cool. Think about it, it's not an easy task without pattern matching. But I will not talk in this session more about my work at MoveIt. We will use the Eurovision winners for learning pattern matching. If you are not familiar with the Eurovision Song Contest, here are a few slides of introduction. The Eurovision Song Contest is an international songwriting competition featuring participants representing primarily European countries. Each participating country submits an original song to be performed on live television and radio, with competing countries then casting votes for the other countries' songs to determine a winner. Eurovision has been held annually since 1956, making it one of the world's longest-running television programs. 52 countries have participated at least once, each participating broadcaster sends one original song of 3 minutes duration or less to be performed live by a singer or group of up to 6 people aged 16 or older. So I created a table, and I have a record for every year of the contest, starting with at 1956 until the last one this year. So we have the year, the winning country, the song name, the performer, points, language, and the host country. So let's start analyzing the Eurovision Song Contest. And we'll start with a very simple question. We want to find all the wins of Luxembourg. Now, there is a trivial solution, right? Select star from Eurovision winners, where winner equals Luxembourg. But this is too simple. Let's do it with pattern matching. Now, don't get me wrong. I don't say that pattern matching is a better solution for this query, for this question, but bear with me. So, to understand the concept of pattern matching, let's imagine that we have a special indicator named Lux for Luxembourg. And we mark every record that its winner is Luxembourg as a Lux record. So 1960 is not a Lux record, but 1961 is a Lux record. No, 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 no. Yes, 1965 is a Lux record as well, and so on. And now we define a pattern based on the Lux indicator. And in our case, the pattern is very simple. We are simply looking for a Lux record. So this one is a Lux record, 1965 is a Lux record, and so on. In pattern matching in SQL, we call this indicator pattern variable. So let's write the query. We select from the table and we add the keyword match recognize. We define the pattern variable Lux using some Boolean condition. In this case, the condition is winner equals Luxembourg. And we define the pattern. And as I said, the pattern in this case is very simple. We are looking for a Lux record. All rows per match. I'll talk about it more later. And that's it. So this is our first match, 1961. This is our second match, third match, fourth match, and so on. And I executed the query, and this is the result. So we can see that Luxembourg won the Eurovision Song Contest 5 times. Let's change the question just a little bit. Instead of looking for all the wins of Luxembourg, we are looking for 2 successive wins of Luxembourg. Now, think about the trivial answer from before. It doesn't help, right? We need to write something completely different, maybe a self-join, maybe analytic functions, but it's something different. The pattern matching solution requires only a small change in order to solve this question. And actually, this is the type of problems that pattern matching was born to solve. We use the same pattern variable. Define Lux as winner equals Luxembourg. Now, since we are talking about successive wins, we have to define the order. Successive with respect to what? So in this case, the order is by the year. And actually, if you have a pattern matching query without the order by clause, then most probably we have a bug, because it rarely makes sense to find a sequence of rows without defining the order of the sequence. We define the order by inside the match recognize clause. So we added order by year. And now the main change is only in the pattern. Instead of looking for a Lux record, we are looking for a Lux record followed by another Lux record. This is called pattern concatenation. And we have one match 1972, 1973, we have two successive wins, two successive lax records. Now, take a look at these two records. Actually, I lied to you. I said that the pattern is defined by the variables, but the opposite is true as well. The variables are defined by the pattern. This is a composition of the variables and the pattern defined together what we need to achieve. So these two are not lax records because the pattern requires two successive lax records. So these are not lax records, they have never been lax records. Executed the query and we got the result. Now, what if we wanted 7 successive wins? Concatenating lax, lax, lax 7 times is not very nice. So we have a shortcut. We can write lax 2 in curly brackets to represent 2 successive lax records. The result is the same, and this is called pattern quantifier. There are several types of quantifiers. We've seen already that X represents 1 occurrence and Xn represents n successive occurrences. This syntax is for at least n successive occurrences. This one is for any number between n and m successive occurrences, and this is for at most m successive occurrences. And we have even shorter shortcuts. X star means 0 or more, X question mark means 0 or 1, and X plus means 1 or more. If you are familiar with regular expressions, you already see that we are using here the regular expression syntax. So let's change the question now to finding 1 or more successive wins of Luxembourg. It's the same query as before, we only change the pattern. And since we are looking for 1 or more successive wins, we will use the plus quantifier. So lax plus means 1 or more lax records. Same order by same pattern variables. And here we have our first match, which is a 1 win. The second one, the third one, we have here 1 or more. So we have 2 lax records. And this is the result of the query. Now let's compare the first query and the last one. When we asked for 1 lax record, we got these results. When we asked for lax plus, 1 or more, we got this result. And these 2 result sets are identical. But there is a significant difference between them, and this is the match. A match is a consecutive sequence of records that matches a specific pattern. So obviously, we want to see this match. And we can do it. We use the measures keyword. In the measures part, we can define additional calculated expressions. And one of them is the special function match number. So we add match number here, and we add it to the select list. And now, when we execute the queries, we can see the difference. In the first query, we had 5 matches, each one with a single record. In the second query, we got 4 matches. Match number 3 includes 2 records, 1972 and 1973. Match recognize is an operator. It gets an input record set and it returns an output record set. What is exactly the input and the output? This is not the input, the select star from the table. The input is the table that comes right before the match recognized keyword. And the output is what we see here in the rectangle. So if we want to add an alias, we will add it at the end, right after the match recognized clause. We don't have to use the whole table as the input. We can use a subquery using an inline view. So in this example, I'm taking only the years between 1990 and 2000, and the columns year, winner, song, and host. Now, let's have an example with more than one variable. Until now, we used only one variable, lux. So I'm using this subset, the subquery, as the input, and I'll use the order by year. We want to get the match number, all rows per match. We'll talk about it later. And now I want to define the variables. I will define 3 variables, nothing really important, just a silly example. The I variable is for records that the winner starts with a capital I. LN for long name is for records that the song name is 18 characters long or more. And UK for records where the host country was the UK. The question marks here represent potential records for each variable. Why only potential? Because we don't know the pattern yet. And as we said, the pattern and the variables are defined together. So let's add a pattern. We are looking for an I record, followed by an LN record, followed by UK question mark, which means 0 or 1 UK record. So 1990 is an I record. Italy starts with an I, and it is followed by an LN record because the Swedish song here is more than 18 characters long. It is not followed by a UK record because 1992 was hosted at Sweden, but it is okay because the pattern requires 0 or 1 UK record. So this is our first match. What about 1992? Is it really an I record? Ireland starts with a capital I for sure, but the next record, 1993, is not an LN record because the song name is too short. So 1992 is not an I record. 1993 is an I record. Ireland starts with an I, and the next record is an LN record because of the song name here. Once again, we don't have a UK record after that, but it's okay. The pattern allows us to have a match with I and LN only. And we have another match here. In this case, an I record followed by an LN record, followed by a UK record. So we have 3 matches here. Now, until now, we defined, and this is the output, nothing important, as I said. Until now, we defined the variables. Each variable is independent of the others. There is a connection between them, as we saw, defined by the pattern itself, but the definition itself of every record, of every variable, is independent of the others. Usually, in an interesting queries, there is a relationship between the variables. So let's look at a more interesting question. We would like to find 2 or more successive wins of the same country. I don't want to tell Oracle which country. I want it to find it for me, not like Luxembourg in the previous examples. So I expect it to find Israel here and Ireland here, but I don't know it in advance. I want the query to tell me which countries won 2 or more successive wins. So let's write the query. Order by year as before. We want the match number in the output, all rows per match. And now we define the pattern. We start with some record X, which is followed by 1 or more same records. So if 1978, for example, is an X record, 1979 should be a same record. Let's define same. Same is defined as a record that its winner equals to the winner of the previous record in the input record set. And prev for previous and next are special functions used for physical navigation. We navigate in the input record set. What about X? I did not define it explicitly, so it is defined implicitly as any record. It's like defining it here as X as 1 equals 1. And the reason is that every record has the potential to be an X record, to start a match. So all these records potentially could be X records, but they are not, because the pattern requires that an X will be followed by at least one same record. So we reached 1992, and this is an X record because it is followed by 2 same records. And this is the result. And now we know that in the history of the Eurovision Song Contest, there were 3 cases where a country won 2 or more times successively. Let's make it more interesting. We would like to find returning winners after a break. For example, Luxembourg won in 1972 and 1973, and then for several years they did not win until 1983, where they did a comeback and won again. Let's write this query. Order by year, match number, all rows per match, and now the pattern and the variables. We start with some record. I called it A. It can be followed immediately by a same record. Same star means 0 or more same records. And the same, as we defined it before, it is defined as winner equals prev winner. Because I don't consider this a comeback. Okay, we have several wins, several consecutive wins. This is the starting point. And now we are looking for at least one diff record. A diff is a record that its winner is not equal to the winner of the A record in our match. This is a qualifier. We qualify the winner column by a pattern variable referring to our match. If we had more than one A record in this match, this means the last one in the match. Okay, so we have at least one diff record, records that the winner is not the same winner as we started the match. And finally, we want a comeback. So we'll define like first. Like first is a variable for records that the winner equals to the winner of the A record in the match. And we need at least one like first for having a comeback. And we got the result we have 2 matches here. We'll go back to the results in a minute. But before that, I want to talk about 2 very nice features that can be considered as debugging tools inside the select statement itself. The first one is the special function classifier. Classifier, I named it var here and returned it in the select list, shows us for every record in the match to which variable it was mapped. So we can see in the first match, 1972 is an A record, 1973 is the same record, then we have lots of diff records, and finally a like first record. This is very helpful because when we write queries with pattern matching, sometimes we don't get the result that we thought we should get. And using the classifier function helps us detect exactly what happened. Another nice feature is all rows per match with unmatched rows. By default, we get only records that were matched, that a match was found to the pattern. If we add this clause, we get also records that were not matched at all. For example, in our case, 1971, Monaco did not make a comeback. It was not a returning winner in this input record set, so we didn't get it before, and now we do get it. And you can see that the match number and the classifier are null because this record is not part of any match. Let's take a look at the results again. We got 2 matches from 1972 to 1983, and then Sweden from 1984 to 1991. But if we look closer, we can see that Sweden had a comeback even before, between 1974 and 84. And the UK was a returning winner, and Ireland was a returning winner, but we didn't get these results in our final result. And the reason is that by default, Oracle starts looking for the next match in the record that comes right after the previous match, when the previous match ends. In other words, or for example, since the first match ended in 1983, Oracle started looking for the next match in the next record in 1984. We can change this default. We use the after match skip clause. The default is past last row, and the other options are to next row, which means if we found a match starting at 1972, we will start looking for the next match in 1973. To first variable means starting looking for the next match in the first occurrence of some variable, a specific variable, in the previous match. And to last var means starting looking for the next match in the last occurrence of the specific variable in the previous match. So if we want to get all these comebacks that I showed earlier, we need to change our query, and instead of using past last row, we will use to first diff. We want to start looking for the next match at the record of that includes the first other country in the previous match. And I changed the order by to see each match together. And now we can see that we get all the results that we wanted. The first one is, as before, 1972 to 83. And then we got back in time and found the comeback that started at 74 and happened at 84. The third one for the UK, 1976. The fourth one, and so on. And we should be very careful here, because if we change the default, we may get the same record multiple times in the output. It can appear with different roles in every match. So, for example, here, 1980 was a diff record for the first match, the second match, the third match, and it was an A record for the fourth match. And sometimes this is too much information. What if I want to get for every match only a single record with the winner, the first year, and the year of the comeback, and the number of years in between where other countries won? With Match Recognize, we can do it very easily. The query looks pretty much the same. And the main difference is using one row per match instead of all rows per match. Until now, we used only all rows per match, which means that with every match, we get all its records. With one row per match, we get a single record for every group of records that are defined by the match. This is very similar to a group by query, to an aggregate query. And as with aggregate queries, we need to define the records that will be returned, the columns that will be returned from the query. In other words, the aggregates. And we define the aggregates in the measures clause, where we defined earlier the match number and the classifier. So we want to get A.winner, which we already know. This is the winner of the record that is marked as an A record. We want the first year and the last year in the match. First and last are special functions for logical navigation, which means inside the match, the first record of the match and the last record of the match. And we can use aggregate functions, but not every aggregate function. We can use the 5 basic ones: count, max, min, sum, and average, and we cannot use distinct. But we can use this notation. We can count only the record, only the number of records in the match that are marked as diff records. Okay, we can qualify a specific column or star to get the count of records, specific records of a specific variable. And we return everything in the select list, and we got the result. The first match is for Luxembourg, starting at 72, doing the comeback at 83, and 9 years in between where other countries won. What if we want to get the average points of the winner in the match? Now, first of all, don't do it. Doing calculations, average of the points is pointless, because every year is something else and the rules are changing, and it depends on the number of countries participating in the contest in each year. But let's find the average points of the winner anyway. How can we do it? Let's start with something else. Let's find the average points of the other countries in every match. This is easy, right? Because we know that the other countries are all marked as diff records. And as we did with the count, we can do with average. We do an average on the points column of all the diff records. But the winner may be classified as an A record, as a same record, or as a like first record. So we can use another feature of the feature, the subset clause. Subset allows us to unify several variables. So in this case, I define W for winner as the union of A, same, and like first. And once we have W, we can simply add to the measures clause the average of W dot points. And we get the average points of winner. There are much more in pattern matching in the Oracle SQL language. Here are some additional resources. First of all, the documentation. It is pretty good. Keith Laker is the product manager behind pattern matching, and this is his blog where there are many detailed posts about pattern matching. Stu Ashton wrote a lot of stuff about pattern matching. This is his blog. And Chris Saxon has several presentations, good presentations about pattern matching. Simply Google for it. And last but not least, Kim Berg-Hansen wrote this good book about Oracle SQL, practical Oracle SQL. It has 3 sections, and one of them is dedicated to pattern matching. I will add all these resources in the description of the video. Thank you very much, and go play with pattern matching.